Hello all. Am I audible? Yeah. Hello all. I'm Shibly. I lead the security engineering team at Amagi Corporation, and I'm also an architect. Uh, I would like my colleague to introduce himself.
Hi, I'm Shubham and I'm senior software engineer at Amagi.
Yeah. So we are here to present Secure Local Vault, SLV. It's not the one that puts people into space, by the way. Yeah. Before we get to know, yeah, maybe you can. Before we get to know, let's just drill down a little bit about secrets. Uh, we all know that keeping a secret is hard in literal sense. I mean, people, when you share somebody something, it gets on to somebody and then it keeps on going forward, and then you hear it in a different note altogether when it comes back to you, right? So, similarly, secrets in services that we use, engineering as well, it is literally very hard. We have been with Amagi for 2 years now, and it's been really hard to keep people from not having secrets everywhere. We find it everywhere. It's not the fancy detection that prevents a company from a breach. It's usually some random password starting with your company name and ending with 123 is what compromises in most cases. Um, so why keeping secret is hard? Secrets are literally scared everywhere. As I said, it's in GitHub, it's in pipeline, it's in Slack. Whatever tool that you use, somebody will share some secret with you, and then it keeps on going from there. And in many cases, they are actually accessible by everybody. In a typical mid startup, it is everybody has access, at least read access to every repository in the organization, and that when people hard code secret to these repositories, they are accessible by everybody. I have seen people where they bookmark specific commits so that it is convenient for them to go and access these secrets and do some production debugging, um, and things like this makes it really difficult to rotate them, because when we kind of, being a security engineering team, we insist on rotating, and then people come back saying that, hey, this will break this will break that, and so on and so forth. So, and cost of maintaining them, I don't think it is justified. People buy fancy secret managers, and again, it does not solve the problems, and we still find secrets hard coded in the code. And specifically, since it's been like a decade since this cloud thing came out as a boom, and then people are now starting to feel the pain of uh, you know um, uh, the money that bleeds into cloud. So people are trying to move on-prem as well as we speak. Especially our organization is trying to do something like that. And when operating across different clouds based on customer preferences and something that goes into customer environment as well, uh, delivering secrets to these environments becomes harder when we have a complex setup. Some our organization especially uses GCP, AWS, and some are on-prem, and some in their customers' own environment, could be cloud or on-prem. So that makes it rather more difficult to deploy secrets. So, let's look at what is the solution that we have for that. We have something called SLV. It's a secret manager which securely allows you to store and share secrets alongside your code base. So nowadays everything is a code, right? Infrastructure as code, policy as code, what security as code, and now we want to call secrets as code as well. So we want to show a little meme before we get into the practical part. So this is how we feel when somebody comes back and tells us, hey, how do you store secret? And then they say, we just put it in Git, right? That's easy for us to read and build the code. And then we feel like throwing them out of the window. And now we solved it just like that. We want you to hard code secrets, but please use SLV to do that. And why did we develop this? Uh, the important problem statement is that secure secrets could be everywhere. Literally, people actually put secrets into S3 buckets. They expose it on CD, and so I've literally seen that. So we wanted something that could allow people to have secrets anywhere and everywhere, and still make it more secure, so that we don't want to hinder their operations. Now that we have GenAI, people use ChatGPT, Copilot, and everything for development. The dev cycle becomes faster and faster, and when we go back and say that go to this portal, put your secrets, people don't really want to do that. So we don't want people to do that anymore. So we want it to be developer friendly. When we say developer friendly, we actually mean developer friendly. It's not DevOps friendly. In usual organizations, secrets are used during deployments or some build pipeline, right? So we don't want people to do that. Almost everybody handles secrets. So we want everybody to add secrets, but add secrets in an easy manner, and still make it more secure. That's the whole idea. And being a local secret manager, why we built a local secret manager, we intended to decouple the storage and the access that allows you to access the secrets. So ensuring that one doesn't end up the compromise of the whole secrets. And the design principles, users will be able to add or modify secrets, but they will not be retrieve any secrets, because we use asymmetric cryptography, which allows you to encrypt any values that goes inside our vaults, but will not be able to reach. Which means that any developer who's having access to it, one can add a DB username, the other one can add a DB password, the other one can add some API key that is required to interact with a different service, so on and so forth, right? And command line interface, because all devs, all DevOps, all engineers love a command line, right? So it's a easy thing, but we will not stop there. We'll go to some GUI based services as well. But for now, we are command line, because command line is not just developer and DevOps friendly, it is also pipeline friendly. You can write scripts on command line, you can use command line to retrieve some data, so it's easy for you to work with command line solution. And secrets are since stored and retrieved directly in code, we would like people to treat secrets as code. Especially Kubernetes, if you look at it, there is a native type called secrets, native resource type called secrets, but then you will not find that as a part of any GitOps workflows, because it is secret, right? So there is no point in actually having it in as a GitOps workflow. But then we have functionalities that will allow you to have now secrets as a part of your code base. And since it is all version controlled, secrets being as a part of the code, now the secrets are also version controlled, providing more auditability. When a secret was introduced, when it was rotated, when it was updated, when the access was changed, all that is part of the code. And as I said, access is separated from secrets. Now compromise of one doesn't compromise the other. So I'll let Shubham take over from here.
Before we get into what SLV is, let's try to understand some key components about it. So the first one being profile. So it's a collection of the environment metadata and policies, and it is mainly intended for a group or organizations. Consider it as a IAM policy, where you set some policy on AWS and say that, okay, this user can actually access this kind of data, not more than that. So that is what the profile here is. The next one is environment. So it's application or service environment, such as cluster, CI, system, or you can consider as a user. And the next is vault. It's a simple YAML file that is going to hold all your encrypted secrets. So we are insisting on saying you can have your secrets as a part of code, but not a plain text. It's actually encrypted secret that you're going to keep it into this vault file. So what are the workflows that we are going to talk about? So first we'll talk about the installation, how we can do. how to create and manage environment, followed by how to create a vault, add secrets into it, how to share this secret with other environments, and what is the integration that we have. We have with KMS, we do also support Kubernetes, and we have GitHub Actions for it. So any GitHub CI/CD pipeline, if you're using, let's say, GitHub Actions, so using this is going to be very simple. We have the GitHub Actions, you just add it into your workflow and you're good to go. So for the installation, we do support Homebrew for Mac users. For Linux and Mac user who want to use shell, we have the curl command. And even for the Windows users, you can use it through the PowerShell. And just in case you want to try it out, how it works, you can also use the Docker. So let me just make this full screen so that it's visible to everybody. So we ran the curl command. We are exporting the environment variables. Once we set this, we can just ready to use it. So this is required when you are using the shell option. If not, if you are using Homebrew, it takes care on its own. Docker as well, you don't need to do anything here. Coming to the profile. So as mentioned, it's a way to manage your metadata about the environment, and it's basically a recommended way. It's not a hard and fast rule you should have a profile, but keeping a profile lets you actually manage your metadata information in a better way so that you can share this environments to other users. So we do support sorry. So there are two ways how you can actually manage SLV. So one is a Git-based, the other is a non-Git-based. So non-Git-based is like when you are a single individual developer where you are working and you don't care for anyone else using it. So that's where you can go for a non-Git-based one. Git-based one allows you to sync your profile with GitHub. So in an organization or a group, there will be multiple developers who will be working. So they can actually update their profiles, update the environments that are in use using the Git. So it supports all of that. And you can see the commands. Let me just zoom in. Oh, mouse is not showing up. See here. It goes away.
I think this is causing some problem.
Yeah, that it is going away.
Mouse is not coming up. I think this is fine.
I think there is some issue. So let me know if you can see it in the video here. So we went ahead and created two environments. One was for non-Git profile. The other one for the Git, where you need to connect your GitHub account. So you'll enter your credentials. Then we are listing the profiles that exist. So if you notice the one in the green, that is the first profile we created, and that sets it as a default profile. So you can have multiple profiles. Then I'm trying to do a poll, assuming there are other people who are also using SLV with Git-based. So it will let you pull all the profiles that exist. So this is the local setup we are doing right now. Once you have created your profile, you can go ahead and push your profile so that this profile can be available for others as well. You can go ahead and delete a profile in case if that's needed. So now let's talk about environment more. So this is our admin user. He interacts with our SLV client. This goes ahead and creates two things. The first one being the environment secret key that gets stored in your KMS or secret store. The other thing it creates is the environment public key. Now let's see SLV environment more. So as mentioned, SLV environment are runtime environment which are going to be used by your pipeline CI, and you can create two types of environment. One being a local user environment, just the one that we talked about, single individual users. The other as a service. So where you are going to use for the service is, let's say, your pipeline. So you do not want to interact with the like you will have to enter the password or other things where you will not have the option to interact with the pipeline. So that's where we will use as service. And user is when you are using certain secret locally. So you have got a vault that is shared with a user as well as a service. So when you as a developer, when you are trying to debug certain things, you would want to know what the secret is. So unless the vault is not shared with you, you will not be able to decrypt it. But when it comes to service, so the service is complete a different environment. So in your pipeline, maybe your DevOps team might have actually configured this for you, and the pipeline works fine, but maybe on your local deployment it fails. You want to debug that. So that's where user environment is going to be useful. But when you try to interact with the user environment, that's where it is going to ask for your password. This password is created at the time of when you create an environment. So we'll see that. So let me replay the environment one so that it gives a better idea. So I went ahead and first created an environment. I named it as for the self, that is for the user, and it is asking me for a password. So this password would be required at the time of decrypting the secrets. Then it gives me a environment definition, and there is a secret binding. I run a GitHub actions for this so that it syncs with my profile. So my GitHub action runs to add this environment into our Git. Now this, the next one that we did was for a service where we created an environment and it gives me a secret for it. So the secret key would be used in order to retrieve the secret. So there won't be an interaction where it asks you to enter the password. Instead you can set an environment variable, and this environment variable will have your secret. And I'm listing down the secret with the tags that we have used for creating. So this option is only available when you use the profile one, Git-based. So that is where it has the metadata. Now how do we create a vault? So we have the SLV client, then we have our developer. They use their environment public key. This environment public key is just before we created the environment. They use that. Using their key, it goes and creates a YAML file. This is the vault file. Now let's see how we can create this. So all the vault, the secrets that we keep in a vault, they are going to be all encrypted, and you can create as many as vault you want. Maybe you can have a backend service that uses some kind of credentials. So you can have a vault file created called, let's say, backend.slv.yaml. You may have for front end that may have something else. You may have certain credentials that are going to be shared across the service. You can have it as common.slv.yaml. So when you create this vault and you share it, like make it as a Git-based, so that's where it will allow you to do search actions. So I create a vault, I name that vault as Shubham, and then I go and create another vault, I name it as Shibly, but both of us belong to a security team. So I may want to share that secret with among our team, so I can use a tag where I call that tag as let's say security engineering. So I can use that tag to share it with other environments. So let's see how it creates. You see we have two environments here. So we went ahead and created a vault. I looked in, so there are two ways actually to share a vault. So one is using the search operation with the tags. The other is when you create an environment, you get a public key. So you can use the public key to share it. So these are the two vault files that we have created. You can see there is a public key available. So now I'm trying to share this vault with the public key. let's see how we can add a secret. So we have our developer, SLV client, we have the vault ready from the previous step. Now the developer puts in a secret by interacting with the SLV. The secret is now added into the vault. Just a single line command. So you can add secrets into the vault by different ways. One is running it into a single command, and that will be like a plain text. The other is an interactive way where you are going to pass in your secret, like you will interact with the standard stdin, and that will insert the secret. And these secrets can be shared with other environments as well. So if you see the second step here, this is the interactive way by which we have entered this. So I'll replay it once again. So here I'm adding a secret into the vault cats.slv, and the secret is Tom. Then you see there is a SLV data cat1. This is the encrypted text that you see. Now in the next scenario, I'm adding another secret into the vault docs.slv, and I'm interactively adding this. So if you notice, when you interactively add the secret, it does not display the contents of the secret. Now let's see how do we read a secret. So this is our application environment. We have our application runtime. It can be your CI/CD, or maybe locally you might be interacting. You have your SLV, you have the KMS or a secret store, you have your vault file. Now the developer talks with SLV. SLV then goes ahead with the KMS or the secret store. It gets back the secret key. Then the secret key is being used with the vault. This goes and unlocks your vault secret key. Using the vault's secret key, it goes ahead and unlocks your secret. And once the secret is unlocked, this goes back to the SLV, and SLV then sends it back to the application. So your secret is now back with your application. So now you can use your secret. So let's see how we can access this secret. So in the first case, if you see, we are trying to access a secret from cats.slv. Since it was shared with a self, so you are supposed to enter the password. After entering the password, it shows your secret as Tom. Now I have set a environment here, slv env secret key. With my secret, I'm able to actually go ahead and retrieve my secret. So until you do not enter your secret key, set that as an environment variable, you will not be able to access the secret which is shared with a service. So for the service, it is always the secret key, and for ourself, it is a password. Now let's see how we can share our secret with other environments. So other environments, once again, you can consider it as an user. So I may have a user, so I'm an environment. Shibly is an environment in that case. So before you share any vault, you must first yourself have access to it. If you do not have access, you will not be allowed to share this. And if you look at the video here, we are first trying to get the secret for cats. We enter the password, it gives me the secret. Then we try to access the secret for docs.yaml, docs.slv.yaml. I enter the password, but I do not have access because these were two different environments that were used. So So here we tried to access the secret using our credentials. It didn't work. Now I'm setting the secret key here. I'm setting the slv env secret key. Once I set that, again I will try to access the docs.slv.yaml. It retrieves the data, tells me Scooby as a dog name. Now I go ahead here. I try to add a access. So if you see the command I'm running, I'm trying to add access to this vault. To the user, if you see, there is a environment search. I'm going ahead and searching which environment I want to share it to. So I'm trying to share it with self demo. Once that is done, the vault gets now shared to this user. Earlier when we tried to access, it gives an error, vault is not accessible. Now once this is done, I will go and unset the environment variable so that this environment variable is no longer available in the memory. Once this is unset, I will again try to access the vault by entering the password this time, and this will retrieve the data for me. So this is how we share the vault with other environments. Yeah, now over to Shibly.
So before we go, I would like to ask a question. Have anybody of you used a local secret manager that works on cryptography? Anybody? There, what was it? GoPass. SOPs. So we have three things that we narrowed down. One of them is SOPs, of course, and the other one being Bitnami sealed secrets, and the other one is eJSON. I think you would have heard about it. eJSON also works based on asymmetric cryptography. So these are the three things. And does any of you know what is quantum safety? Quantum safe cryptography? Any terminology on that front?
You take any particular signature or anything, right? So that can be easily tampered if you do some 2 million or 3 million computations. You can easily decrypt the encrypted whatever you have. Use the help of quantum computers. So we have something called as quantum resistant encryption, which is currently
Okay. Yeah. Fairly. Yeah. Right. So to make a little bit of more brief idea on what it is all about. Today's symmetric cryptography mostly used is AES 256, which is still not yet proven to be unsafe from quantum attacks. However, the most common asymmetric algorithms, being elliptic curves or RSA, are not that quantum safe, because there was an algorithm that was proposed, which is called Shor's algorithm, sometime in the 90s, which is theoretically it is able to factorize two large prime numbers, which is the basis for most of these asymmetric encryptions, right? These, though being asymmetric encryption, underlying it still uses symmetric cryptography for large amounts of data, but the key is still encrypted with asymmetric cryptography. So what SLV uses, we use Argon 2 ID, which is 2015 winner of password hashing. It is memory hard as well, and compute hard as well at the same time. So we have 32 MB of memory that is required to hash a password, and it goes through 32 iterations, which is practically something not at all close or possible to hash with any number of GPUs that exist today. Even I think OpenAI or NVIDIA with a large number of GPUs can't crack it. That's the whole idea. And that is exactly what we use for whenever Shubham typed in the password, right? So that's what happens. It takes a little bit of time to hash the password, and then from there it generates the key. And we use curve 25519. It's a specific elliptic curve, and we use that for asymmetric cryptography, because the key length is smaller. It is just 32 bytes. So we wanted it to be more intuitive, and then we thought which one to go, and we were first thinking on the lines of RSA, which is quite time tested, but then this is also quite good. It is being used in TLS 1.3, and we went ahead with this. The key length is small, and it is easy to share as well. I know that we don't want to encourage you to share secrets. I'm actually talking about public keys. So I think it is completely safe to share public keys. We have abstracted our tool enough to not show you secret keys. Whatever demo that we have here is to make your make it simple for you. So that's why you are seeing a lot of secret keys as well. And we use Crystal Skyber 1024, which is a NIST approved standard for post-quantum cryptography. It is quite large. The public key is like 1.5 kilobytes, 1500 characters plus. So it's an optional aspect of SLV. You just need to specify a Q flag in every operation that you do, in case you would like to use a quantum safe algorithm. but it's completely the decision of whoever is using it. If they are too paranoid about the quantum computers coming and breaking your encryption, because we are not dealing with some data that is going over internet that is stateless. We are dealing with something that is going to be stored in your Git repository. So let's make sure that it is not mined in future and being broken, right? So it's up to the developer to take that decision. And we use XCharger20 Poly1305 for symmetric stream cipher. The reason being, AES does not comes with built-in authentication, and this one is much faster and also has built-in authentication, and we built based on this. As such, entirely SLV consumes a library called Zypher, which lies as a backend for this, where we did experiment on how we can do a password-based asymmetric cryptography, and then from there we derived the whole idea. It's a small library that we built, and then we wrote SLV on top of it. SLV is meant to solve the problem of large organizations. Amagi, the company that we come from, does broadcasting for TV channels. Our most important problem was that our customers were using their own servers sometimes, and for broadcasting, and sometimes it is AWS, sometimes it is GCP, and it was very difficult for us to put a centralized vault, because some of our customers are behind firewall who don't even have their applications deployed, don't even have outbound internet access. So we wanted something that can run locally, and we wanted something also that has zero knowledge encryption, meaning customers get to generate their environments, they share their metadata which contains public key, and then we put in secrets and then send it back to the customers, and they deploy it. We just get access to one deployment repository, and that's it. We put all the secrets there, and it works fine because customer only can access the secrets. This also gives a confidence to the customer that a trust is built now. Now the customer knows that only they can access the secret. It's so they feel confident about it. And the current features include Kubernetes support. We have an operator that reconciles secrets and writes it as Kubernetes native secrets. So we have a specific resource type called SLV, which looks exactly like Kubernetes secret object, and that gets converted into the same, reconciled into the same namespace as secret Kubernetes native secrets object, so that we wanted people to not do a lot of code change, right? People use secrets, Kubernetes secrets, and we were aware of it, and it should be easy for them to move from hard-coded Kubernetes secrets or secret resources to SLV resources. So this makes it a lot easier. And we have GitHub Actions, which Shubham will talk about, and we have KMS providers for GCP and AWS. And as we mentioned, we have quantum safe cryptography, and we have keyring support for most platforms, so that you don't have to type in your password every time. Whatever that you saw there, Shubham typing in the password all over again, that was a container, so he had to go through that. If it was a dev machine, you don't have to go through that pain. And we have something like Python virtual environment, where you say SLV vault shell, and then you just point it to a vault. It just creates a virtual environment where all your secrets are available, so that you can try out your code locally with all the secrets available in the environment as environment variables. And we also have native bindings, C libraries, SO, DLL, DLL, all native bindings available, so that it's easy for you to integrate with any programming language for that matter.
So what we are now planning is, we are planning on adding support for Terraform, add support for Azure KMS support, telemetry, then client libraries for most popular languages, let's say Java, you can have Python. So then more CI platforms. Currently we support GitHub Actions. We'll try to bring in more features on that. Web client app support. So this is all CLI based. We'll try to add more support for the web client and support for WebAssembly. So any of you interested, you can look at the code base. So it's open source. So you can scan the QR code. You can also look at the demo videos that is available. So all the demo videos that we talked about, it's all available. You can see at your own pace. GitHub Actions.
Just scroll.
So this is our repository where we have our code base. Here is the GitHub Actions that we talked about. So all you need to do is, yeah. So this is the step that you're going to add it into your existing GitHub Actions. So this is our repo where it will contact with. You are going to mention your vault file name that you want to use for your environment. And this is going to be your environment secret key that we used earlier. So your environment secret key, please do not hard code this in your code. This is supposed to be added into your secrets. Otherwise all your existing secrets that you have encrypted is all going to be decrypted. You can also add a support for prefix. So let's say you develop an application, call it as XYZ. You may have environment variables with different names, but you only want to inject those environment variables with your project name. So you can have your environment variables always prefixed with your project name. So XYZ underscore, and you can have any string after that.
And we have enough documentation on Kubernetes part. I know that if you look at it, there could be some documentations that are missing. We are still working on it. This is fairly a year-old project, and there is enough documentation on Kubernetes, however, to cover how to set up your Kubernetes operator and then reconcile a secret and so on and so forth. SLV natively works with current Kubernetes context, meaning somehow how like Bitnami seal secret works. You just need to say create a vault for this current context Kubernetes cluster, and it'll create a vault, and then you just apply it, just runs it. I'll also give a little bit of demo on how it works. So I have a default namespace. I'll quickly create a vault for the Kubernetes operator. And then I want it to be shared with myself, and then I want it to be shared with K8s. And also I need to specify a name for the K8s resource. Let's call it test, and I just create a vault now. It has been created. So this is how the vault looks like. It's just a YAML file with a bunch of values. So these are wrapped keys. So basically how SLV works is that I involve a technique called key wrapping. So we have a concept of environments and we have a concept of vaults. Every vault has a keeper, and we have a Is that okay? Yeah, so we have environment keys, and then we have vault keys. So when a vault is created, you are mandatory. It is mandatory to provide at least one environment. So when a vault is created, SLV generates a key pair, keeps it in memory, and then on the fly it encrypts your vault secret key with your provided environment public key. If you look at this command, I have specified env self and env k8s. It pulls out the public key from Kubernetes context and the self environment which is registered to my local laptop, and then it adds these three values which are actually the secret key of the vault being encrypted with three different keys. So to look at who all have access, You just need to say x.slv.yaml and it gives you that it's currently being accessed by root, self and unknown. Root is a common user which will be added to all vaults that are created in your organization. So that's how it works. And now that we have created it, I'll quickly add a secret to this vault. And then I'll add my cat's secretive name. Now I'll navigate to the namespace default. Let's wait for secrets to come in. All you need to do is the same way you apply any Kubernetes resources. Use kubectl, apply, and then say x.slv.yaml and done. You will have it right here. That's my cat's name, by the way. Now, so that's all we have. Do you have any questions? Yeah. Yes. Private keys are also stored in the YAML file. If you look at it, it is encrypted with the environment's public key. Only with the environment's private key, the secret key. That is supposed to be stored in the environment where the secret is actually required.
So all the things are stored somewhere in the local only, right?
Yes, the keys are not stored in the local. So SLV has KMS integration as well, where you don't even get to see any of the keys for that matter.
So the KMS, that's where the public private keys are stored.
Yeah, KMS or any secret store that you want to have.
Basically, we need to configure the KMS. It can be Azure or like AWS or
Yeah.
GCP, and
Yes.
that's where the private keys.
Yeah, that's what we have. Current integrations with AWS and GCP, wherein you initiate your AWS.
That configuration need to be done here. Like
Yes,
this.
yes. So that is a responsibility of somebody who runs the environment. But it's usually the SRE or DevOps
Okay,
team
so
in an
the
organization.
configures, the admins, they do the KMS
And then they put it into a profile, which Shubham explained, where everybody gets to see what's a profile, and the public keys are listed in the profile as well. And then you just need to say, I need to share it with X production environment, and then it's shared. No keys are visible now, and every developer gets to put into this vault, and that secret gets into the production environment.
So there is one KMS vault that for the org level, and this for the local vault at the project
It
level.
need not be. You can have multiple KMS.
So
You may have multiple services, products. So.
one is required for SLV, and that can be in even centralized KMS, and that's where the private keys were stored, and this is for the local at project level.
No,
Can I take that way?
we would prefer that you have multiple KMS or secret store or whatever it is for each environment that you configure.
Got it. Fair enough. Thank you.
Anything else?
Yeah, one doubt is like when we compare with HashiCorp vaults, right? So what is like what you compare with the standards like revocation of the secrets or dynamic secrets creation? Like revocation of the secrets, I mean in the sense like if your secret is not being used for a certain point of time, you're revoking that. And for dynamic secrets, like if I want to log into a particular database, like for a particular, there's a test database, I just want to give him access for like a particular token time, like 2 hours, 3 hours, those kind of stuff, like a dynamic secrets, which is already there in HashiCorp, right? So I just want to know like how you manage that here.
So in our organization, what we use is it's fully Kubernetes based, and there is an operator called reloader, right? Which when there is a change in secret, it will be able to observe where all the secret has been used. Not just secrets, it's just any metadata for that matter, config maps, secrets, and it will be able to restart the pods for these services that are consume these config map or secrets, and when the pod restarts, the mounting logic or whatever that you have reloads the secrets, and that's how rotation happens. Did I answer the question?
Yeah, but do you have a specific policy to revoke the secrets? Like you maintain that in a separate way or anything for revoking the secrets? And
Yeah, so revoking a secret, we don't have a method. It's a manual approach. We don't know what is the secret, right? So it could be an API token. We don't want to go into that part where we handle the rotation and all that, but we allow something where you can remove a secret or revoke an environment as such, where we redo the entire cryptography of the vault, meaning we rotate all the keys that are used to encrypt the vault, because when you remove a user, the commit always goes into the history, right? Which means that anybody can go back and read that commit if they, provided they have access. That's what we said. We separate the storage and the access. So anybody leaving the organization and still having access to the repository, we don't want that kind of. We have faced these incidents and we don't want to go into that path. So what we do is we have a command where they can remove a user from a vault. What actually happens is when you remove that, you need access to this vault. It decrypts the environment and then finds out who all already have access, removes that one guy out of it, and then re-encrypts the whole vault, whole secrets as a whole, so that any further changes to the vault is not visible to the existing user who was removed.
Thanks. Hi, that was a good tool you have showed. Thanks. So the one problem that we'll be facing in terms of the development life cycle is the zero trust actually. So we were talking about the KMS, right? So for setting up a KMS for a single user account also, you need to have that. If you take AWS, then I need to have an AWS secret token and the secret key stored initially. Again, I have to have that overhead of storing them as an environment variable, and then that is going to support SLV and any other things that is in the market, right? Is there a way that zero trust can be gained in terms without storing the...
So KMS does not actually store your secret key.
I'm not worried about KMS having the public key or the secret key, right? What I'm saying is the initial zero trust between my machine and the KMS store, which is the AWS, right? So to have that communication to happen, I need to have the AWS secret key and token.
Right. No, not necessarily. So we have two approaches where you need to set up your AWS KMS, AWS IAM role in your machine, and then you connect to the KMS, ask that KMS to encrypt your secrets. We can always say that I'll only my DevOps can allow only encrypt permission for this IAM role where this entire process happens, right? But we don't want to go into that difficult path. So instead we support two different algorithms. The one that is native, which is AES 256, supported by most KMSs, and then we also support RSA 4096, where they don't have to expose the role. Instead, your DevOps or SRE team can simply share the public key to the KMS, and then you just provide the ARN to the resource, and it just happens. Yeah.
So the communication will not happen.
There is no communication at all.
Got it. And one more thing is templating, in terms like for not only for Kubernetes, for any other processes, right?
Yeah.
So in terms for...
So we did not explain a lot of the features because we know that we would run out of time. We have something called referencing and dereferencing, where you can specify a template, but we wanted secrets to be stored in the vault. However, you can, if you look at this, there is something called uses pattern as a placeholder, right? So you can have any file and then use this pattern, and your secret name is something that we have here, mycat, and you put it in any file and then call dereference. It will simply replace it with the actual secret. I hope you were asking about this.
Yeah. Similar to this. Yeah. Okay. And then if I already have an YAML file which is having secrets, right?
We also support that.
In terms of
importing
only the passwords, not the
metadata. We do that. Yes.
Okay, thanks.
But currently we import the entire YAML file as such, and reference. That's what is referencing. We meant by referencing. We support YAML and JSON, where we move the values from here, put it here, and then references from there, put it here, so that it's easy for you to dereference. For now, we don't have an option to select specific keys, but we'll bring in that. Yes. Anything else?
So how does this differ from seal secrets in terms of Kubernetes operator? Seal secrets.
Seal secret. So seal secrets is specifically only for Kubernetes, where the where the environment is managed by Kubernetes itself. They have a very complex way of porting that environment outside. What happens when the entire Kubernetes cluster is blown out? We really don't know what happens. I'm not saying that will happen, but Kubernetes, as we mentioned, we built it for developers, not just for DevOps folks, right? So we want, when there is something that goes into seal secrets, something like seal secrets, we also have similar functionality what I showed, and we also want that secrets to be accessible by somebody who is sitting outside the Kubernetes cluster, somebody who doesn't even have access to the Kubernetes cluster. Say for example, I've shared it with 2 different environments and I'm still able to access it, and I can go inside a Kubernetes cluster and still be able to access it. That's the whole point. Kubernetes seal secret gives you only one environment, but then now you can share your same vault with 2 different clusters.
Okay, thank you. Is this an open source?
Yes, this is an open source project. It's completely free and open source. No open core and all that gimmick. It's always open source because it doesn't have anything to do with our company's business. So it's completely open source. Yeah. Yeah. Thank you all.
Thank you.